All right, everybody, welcome to another deep dive. Today, we're going to be taking a closer look at something that's pretty amazing, and that's computer vision,
Yeah.
and specifically object tracking,
Right.
which is something that you might not think about every day, but it's all around us.
Yeah, it is.
It's in our phones and computers, and it's also in things like self-driving cars.
Absolutely.
And even security cameras and all sorts of pretty advanced technology that we use every day and we got to take for granted.
Yeah.
And so today we're going to be looking specifically at a particular algorithm called mean shift,
Right.
which is pretty fascinating.
Yeah.
And really kind of, I think, changed the game in terms of how computers can track objects and how well they can do it.
Yeah. I mean, it was one of the early successful and robust algorithms for doing real-time object tracking.
Yeah, yeah. So I think for a lot of people, they might hear that term mean shift.
Yeah.
It's kind of like, what is that?
Right, right.
So so maybe you could give us like the sort of mean shift for dummies version. Like what's the basic idea here?
Yeah, so the basic idea is pretty simple, actually.
Yeah.
If you can imagine trying to find a friend in a crowded park and you know what they're wearing. You know their visual fingerprint, so to speak.
Right.
And so mean shift does something very similar.
Okay.
It takes a fingerprint of the object, usually by analyzing its color distribution.
Okay.
And it uses something called a histogram to do that.
Right.
And then it scans the image, looking for the area that best matches that fingerprint.
Gotcha.
So, you're basically comparing the object that you're tracking to every other region in the image.
Yeah, so it's like it's taking a snapshot of what it's supposed to be looking for, and then it's kind of going through and comparing.
Exactly.
Okay,
right.
cool.
So, the key here is this idea of color distribution. And how do we represent that? Well, we use this thing called a histogram.
Right.
Now, histogram, that might sound a little bit technical, but it's really just a bar chart.
Oh, okay.
That shows how often each color appears in the object.
I see.
So, if you have an object that's mostly red, the red bar on the histogram is going to be very tall.
Right.
And if it has some green, the green bar will be shorter and so on.
So it's really like it's creating like a color profile.
Yeah, a color profile or a color signature.
Yeah, what it's looking for.
Exactly. And then it uses that signature to compare to other parts of the image.
Okay, that makes a lot more sense now.
Yeah.
So it's got this color profile. It's comparing it to different parts of the image, and it's basically, like you said, trying to find a match.
Right.
But how does it actually like shift towards the object? Like what's the actual process of that?
Yeah. So that's where the mean shift part comes in.
Okay.
It's actually an iterative process.
Okay.
So, it starts at some random point in the image, and then it repeatedly shifts towards the region with the highest similarity in color distribution. And this shifting is based on the mean of the distribution, which is where the mean in mean shift comes from.
Right, right.
And so it keeps doing this, shifting and calculating the mean and shifting again until it converges on the target object.
Gotcha. So it's like almost like a heat-seeking missile or something.
Yeah, kind of like that.
It's like honing in.
It's honing in on the target.
Yeah. Okay.
Yeah.
So that's how it actually like moves towards or finds the object in the image.
Right. And this iterative process is actually very efficient.
Okay.
And it can converge very quickly.
So that's why it's used for real-time tracking, because it can keep up with things as they're moving.
Yeah, it can handle dynamic scenes.
Gotcha. Okay. So it sounds pretty cool, and it sounds like it's pretty good at what it does. But like anything, I imagine it's not perfect.
Right.
So what are some of the things that can trip it up?
Yeah. So there are definitely some limitations.
Okay.
One of the biggest ones is scale changes.
Okay.
So if the object that you're tracking is moving towards the camera or away from the camera, and its size is changing in the image,
right,
that can throw off the algorithm.
Oh, I see.
Because the color distribution is still similar.
Yeah.
But the size is different.
Gotcha. So like if a self-driving car is trying to track another car.
Exactly.
And that car is speeding away from it or even towards it, I guess, it could have trouble.
Yeah, it could have trouble because the size of the car in the image is changing.
Okay. that makes sense.
Another limitation is lighting variations.
Okay.
So if the lighting conditions change, if it goes from sunny to cloudy, or if the object moves into a shadow, that can also affect the color distribution.
So it could think it's a completely different object.
Yeah, it might think it's a different object, or it might lose track of the object altogether.
Oh, wow. Okay, so lighting is a big one too. So scale,
Yeah,
lighting.
right.
Are there other things that can kind of mess it up?
Yeah, there are. Things like occlusion,
Okay.
where the object is partially or completely hidden,
Uh-huh.
can be challenging.
But I thought you said it was actually pretty good at dealing with occlusion.
Yeah, it is. It is robust to partial occlusion.
Okay.
If a small part of the object is hidden, it can usually still track it.
Right.
But if the object is completely hidden for an extended period of time,
Yeah.
then it might lose track.
Okay. That makes sense.
And then, there's always the computational cost.
Okay.
Mean shift is a relatively computationally intensive algorithm.
Yeah.
So, if you're trying to track objects in real time on a low power device, that could be a challenge.
So are there sort of workarounds for these limitations? Or is it just kind of like, it is what it is?
Yeah, so there are definitely techniques that people have developed over the years to try to address some of these limitations.
Okay.
For example, for scale changes, there are adaptive mean shift algorithms that can adjust the size of the search window as the object is moving.
Okay, cool.
And for lighting variations, people have used things like color spaces that are more robust to lighting changes, and so on. So there are definitely ways to improve the performance of mean shift in these challenging situations.
Okay, that's good to know.
Yeah.
So so it sounds like, even though it's got some limitations, it's still a pretty powerful tool.
Right.
And I imagine it's being used all over the place.
Yeah, it's used in a wide variety of applications.
Okay, so what are some of the coolest or most interesting ways that it's being used out there in the world?
Yeah, so one area where it's used a lot is surveillance.
Okay.
So you can imagine security cameras in a public space.
Right.
Mean shift can be used to track individuals or vehicles,
Right.
In real time. And that can be used for things like security monitoring.
Gotcha.
Or even, identifying suspicious behavior.
Yeah, yeah.
So that's one area.
Okay, so that's kind of like the Big Brother application.
Yeah, right.
What about some less creepy ones?
Yeah, so another area is human-computer interaction. So you can imagine, using mean shift to track hand gestures, and that can be used to control a computer or a video game,
right.
Or even, things like conducting an orchestra.
Oh, wow. That's pretty cool.
So there's a lot of potential there for using mean shift to create more intuitive and natural ways of interacting with technology.
Yeah, that's pretty amazing. So it's like we've gone from, tracking cars and people to like conducting an orchestra with your hands.
Yeah, the possibilities are pretty endless.
That's really cool. So I guess what I'm wondering is, looking ahead, what are some of the things that you think are sort of on the horizon for mean shift? Like, where do you see this technology going in the future?
Yeah, that's a great question. I think one area that's really exciting is augmented reality.
Okay.
So, imagine wearing glasses that can overlay digital information onto the real world.
Yeah.
Mean shift could be used to track objects in your field of view.
Okay.
And that would allow those virtual elements to interact with the real world.
Oh, wow.
So, you could have virtual objects appearing to be sitting on your table, or you could have, information about a building popping up as you walk past it.
Right.
So I think there's a lot of potential there for using mean shift.
That's really cool.
To create these really immersive and interactive augmented reality experiences.
So basically it's like the possibilities are pretty much endless.
Yeah, I think so.
I mean, it's pretty incredible to think about like how far this technology has come.
It's come a long way.
And where it could go.
Yeah, it's very exciting.
Yeah. Well, I think this has been a really fascinating deep dive into mean shift tracking.
Yeah, it's been fun.
And it's one of those things that, like I said, I think a lot of people just kind of take for granted.
Right.
But it's really amazing when you think about what's going on behind the scenes.
Yeah, it's really clever.
And how it's being used to make our lives easier, safer, more entertaining, all sorts of things.
Yeah, absolutely.
So I really appreciate you taking the time to break it down for us.
It was my pleasure.
And yeah, I think for everybody listening, next time you see a self-driving car or
Yeah.
you're using a security camera or even just playing a video game with motion controls,
Right.
you know, just remember that mean shift might be working behind the scenes. And it's a pretty amazing piece of technology.
It is.
So that's it for this deep dive. Thanks again for joining us.
Thanks for having me.
And we'll see you next time.
See you later.
Bye.